Hi, welcome to our 20th tutorial on Erlang. Today we're going to finish off the Mnesia database management system. In today's tutorial, we're going to test the database logic. We are also going to implement the database server and add it into the supervisor. And finally, we're going to add it into the factorial system. The first thing we do now from the previous tutorial is to rebuild the project and run it. To test the database logic, we simply call database logic and we call the init function. And everything is okay. Now we want to store something into the database, so we simply call store db, and what we need to store is the node, so we're going to store the current node and we're going to store a string comment. This is UX learner, and everything is perfect as well. Now let's get the comment we just stored. Well, actually, let's enter another comment again just to be sure. And now let's get the comments we've stored using the current node. So we simply call getDB and we send in the node. This is just basically going to send us back the comments, and we get this is UX learner list and this is UX learner again as a list. The next thing we want to call is getDB2. This one returns the created date or created on variable as well, and we get this is UX learner when it was created, the date, and this is UX learner again when it was created, the date. And finally, the next thing we do is to simply delete db using the current node, and everything is okay. Just to double check, we try get the data and we have an empty list. To stop Mnesia, we simply call Mnesia stop. Information stop. Now that we've successfully tested the database logic, the next step is to write a database server. So I'm going to write a new Erlang file. We select gen server database server. After creating the database server, the first step is to initialize the database logic, and we do this by simply going into the init function and first of all process set flag, trap exit. True. Also, we'll put some kind of information to let us know that the database server is running, so we call IO format and set squiggle p. Starting squiggle then for next line, and then the arguments. So we have global and the name of the module. Self. And finally, we call the database logic init db. So data which initializes the database. We'll save. The next step is a way to store the message. So in the undo call function, we simply call another undo call. Just copy and paste this for a moment. time. And here we want a tuple. The first thing we want is to store, and we need the node name and the comment. So node name, comment, and we want to call the database logic store db function, and we pass in the node's name and the comment. And we output some information to the user to let them know the comment has been stored, so we call IO format comment has been saved for P. So we're gonna, and we wanna mention what the comment has been saved for, and we just say comment has been saved for node name, and we want to reply OK, and we want to reply OK. Perfect. The next function we want to write is another undo call to get the comment. So what we do is, just to speed up things, we copy and paste the first undo call. We change store to get db. We changed store db to get db, and get db takes one argument, which is just the node name. So I'm going to get rid of this, and we want to store the output of the db into a variable called comments, since we're getting the comments. So comments equals database logic get db. Now, since we're gonna get a list of comments, what we want to do is to print out each comment line by line. So we're going to call lists for each, and then inside the for each we write a function fun and a variable cm, simply call and the full comment, which is comments. So that is that. So inside the fun we want to write IO format received. What did we receive? Squiggle p and squiggle n, and then the argument that we received, which is cm, and cm is an iteration of comments. So each comment is a cm, and each cm is outputted. The other function we have to write is get db2. So we copy and paste undo call get db, and we just change this to get db2, and get db2 only takes in one argument and is exactly the same thing, except get db2 also returns the created on atom. So instead of cm we're going to need an atom, because we're going to receive a list of atoms, which is the first one is going to be the comment cm, and second atom, the second value we receive is the created on, so cl, and then we're just going to break this down into cm and cl, and we're going to have received the comment squiggle p created on and squiggle p again. So the first squiggle p is for cm and the second squiggle p is for cl, and we only need the comments, so which is perfect. And reply OK states, and that's all. And finally, well, we need to include the undo call for delete. So we simply just copy and paste the first one, be much easier, and we change this to delete. And delete only takes node name, so we can get rid of variable comments, and it's simply going to call delete db, which takes in one argument, which is the node name, and we'll let the user know something has been deleted. So data deleted for squiggle p squiggle n. And that's all. So after writing the callback functions, the next part is to write the client call functions. The first function we have to write is the store function, and like we all know, it takes in two arguments, node name and comment. So now we call gen server call function, and we're going to call the global module, which is going to be in the first atom, and the second argument is going to be the handle call atom. The second argument is going to be the handle call tuple, which is going to be store, and it takes node name and comment, and that's our first one done. The second is going to be get db, which is going to be the first get db, and that only takes in one argument, which is node name. And same thing, let's just copy and paste this just to speed things up. Okay, and we change this to get db. Same thing, copy and paste. We want to get db2, perfect. Finally, we have to write the delete function, and we're going to call this delete. Delete only takes one argument, which is going to be the node name. So we're going to delete all the comments belonging to this node name. We simply call gen server call, and first tuple is going to be global module, which is basically the name of the module, and we're going to call the second tuple based on the handle call, which is called delete again, and node name, I think that's what's called. Let's just double check. It's called delete. Yeah, it takes a node name. Perfect. Finally, we have to export all the function by calling export and specifying all the functions inside the list. And the first one is going to be store, two argument. Second, get db, get db2, and delete. Perfect. After this, then we go straight into the factorial supervisor, and now we're going to add another specification called Mnesia specification. And here, let's just copy and paste this. So first of all, what we want is the ID, and we're going to call this Mnesia server ID. The function we want to call is going to be, the module we want to call is going to be the database server right here. So we're going to change this to database server, and the function we want to call is startLink, which takes in an empty list. And we want the following strategy, one for all strategy, so if one goes down everything restarts, and we just rename the database module. So everything looks grand. Now we just have to add in the specification into the list of specifications, and we save. After this, the next step is to change the factorial client. This restricts what the client can actually see, so we want them to see factorial recorder. Also, we want them to be able to store comments, so the first function is store comments, and store comment takes two arguments, node name and comment, and we simply just call the database server store, and we pass in the node's name and the comment. The next function we want to allow the user to see is get comment. So we want to get first comment, and it takes in one argument, node's name, and we simply, like before, we just call the database server. Just copy and paste this. Get rid of that, and we want get db. Next function is get comment with stamp. So this time we're going to get the comment with the date stamp, and this is going to be get db2. And finally, we want the user to be able to delete all the comment belonging to a specific node, so we're going to say delete comment, and we call the delete function and pass in the node's name as an argument. Time to export all the functions, so we're going to export the store comment function, get, and finally delete. Now we have the factorial client done. We save it. Finally, we want to change the factorial system and factorial system.app. We change this to version 2, and we want to add in 2 extra modules. And the 2 extra modules will be database logic and database system. Database server, I mean. So database logic, and we want to add database server. Also, we want to register the database server name so we don't have a name collision, and we should actually register the factorial server as well, just to prevent name collision. Mnesia is already here. We just make sure Mnesia is in the application as well, and that's everything done with the factorial system.app. Save. And finally, we go to factorial system itself. Right here we have the start function, which starts the factorial supervisor, and we also have the stop function. Also in the stop function, we want to include Mnesia stop. So we call Mnesia. So whenever you stop the application, we want to stop Mnesia as well. And finally, we just rebuild the project. and we'll run it, and hopefully everything works according to plan. And let's simply run it. So the first thing we do is we want to check all the applications that are currently running. So we call applications, which applications. So currently we only have stdlib and kernel running. And to start our application, we call factorial system. Start. And right here we have factorial supervisor starting, factorial server starting, database server starting. Just expand this a little bit. Next, let's just double check what's running now. And we have Mnesia running, factorial system running. So let's test in three new functions by calling factorial client. And we're going to call store comment. So we want to store the comment for the current node, and I am comment 1. Comment has been saved for node at node host. And let's save a second comment. I am comment 2. Let's print out all the comments belonging to a node. So we're going to call get comment, specify the current node, and we have received I am comment 1 and I am comment 2. Also, let's get node with stamp, and this time I want to change things around by using the full name. So we want an atom node, well, no node at no host. So it's just basically the same thing. You can call the node function or specify the actual node itself, and we have exactly the same comments, but with the exception of the created on time. Now let's try delete the comments belonging to a specific node. So we call delete comment and we specify the node. Here the application has crashed, so let's see what the problem is. So we're going to the database server, and oh, here's the problem. Global was spelled wrong. Global. Now let's just rebuild the project again, and let's run our applications, and let's start the factorial system back, and let's check if all our comments is still saved. Are still saved. Yep, and as you can see, we still have our comments saved on the computer. And let's just try delete them this time. Hopefully it's going to be successful. And we have data deleted for node no host. Let's try get the data again, and we have nothing. And let's try the other one. Okay, comment. We have nothing as well. And let's stop our application by calling factorial system stop. And we have Mnesia stopped and factorial system stopped. Finally, let's check whatever application is running, and we should have stdlib and kernel. Thanks for tuning in today. See you next time.